Hello friends, welcome to the Tech Granth. Today we are going to talk about system design of a railway ticket booking system, and we'll do it with help of IRCTC, which is common in India. So let's look at the functional requirement first. So here the first requirement is that we should be able to search train, and this search should be based on certain criteria like from station to station. We'll talk about all those things in details. Next is once the search is complete, so for that particular search criteria, we should be able to list the trains which is available for that particular route on that particular day. So this is another requirement for us. Once we have the list of train, then we should have the facility to book ticket. So we should be having the facility to book this ticket, block the seat, and we should be able to book ticket into the class that we want. Like if you want to book ticket for first AC, we should be able to book the ticket for that, or if you want to book ticket for a sleeper class, we should be able to do that. Next is payment. We'll not talk deeply about payment. If you want to know about the details of payment, you can check the video on payment gateway that I did previously. The link is there in description. You can check out the playlist of high level system design. Here only thing that we'll talk about is how the payment will be integrated, and the main focus of this whole video will be on the database side. So what I am going to do is that I'm going to describe how you will design a table for each of these functionalities so that your query is really efficient. And in the end, we'll talk about the list of APIs that will be present and a very high level design for IRCTC. But the main focus will be on the table design and how you can design your table in the best possible way so that the query that is going to hit your database should be really efficient, because these are the kind of system where you will get a lot of queries. Then apart from payment, you will have a notification service, because every time you book a ticket, cancel a ticket, your ticket gets upgraded, or if suppose it's in waiting and then it got moved to confirm, so those things needs to be notified to the user. And finally, the reverse flow. If you have booked a ticket and you want to cancel, then all the refund and everything should take place. And for the user account, I am not going to talk about user account service in detail. It's just there because it is one of the key component. But the detail of user account I have covered in a previous video, which is for e-commerce website. So that feature will be almost similar of how you will onboard the user, the new user can be created. So that part will be basically similar. So you can check out that video as well. It's there as part of the high level system design that is there in the description. For non-functional requirement, generally if you are coming up with a website for ticket booking, so it should be highly available. If it is not available, then user experience will be bad. And next thing is that it should be really consistent, because payment is involved, ticket booking is involved. So eventual consistency is not an option here, because when you are going to book a ticket, then in that particular scenario there will be a race condition, and consistency comes very uh, it will play a big role there. So the system should be highly consistent. You cannot give the same ticket to two different person. So that is why eventual consistency, it will not work in this particular scenario. And finally, low latency while search. So when we are doing the search in that particular scenario, the latency should be minimal, so that again the user experience is good. So let's look into the major life cycle. So to cover all these requirements, I have just classified it into few life cycles. So each life cycle will have a certain role to play, and it will have certain importance. So for example, search train, it will have its own life cycle that which starts from you entering, or the user entering the detail of the search criteria, to giving up the list of the train. Second life cycle is booking of the train. So this life cycle starts from once the search criteria has listed the list of train, and from there the user wants to select their class in which they want to book, the date on which they want to book, till they make the payment. And finally, sorry, not make the payment, but till their seat is confirmed. And finally, the cancel train life cycle, which is for the reverse flow of the book train. There will be another life cycle which will be for notification. So notification service will be different, or it will be decoupled from all of these, because it can be used by both book train, cancel train. And even search train can use notification. It can be used in a way like you can send a notification if someone has searched for a particular criteria, like for a particular source and destination condition, and for some particular date, then and they have not proceeded with ticket booking, so you can send a notification to them saying that you looked for this criteria, do you want to book your ticket? So you can send an SMS or email. So these are the four major life cycle that we will cover. Let's look at the first life cycle, which is the search train. Now, when we have to search train, we need some criteria based on which this search will work. So the first thing will be your from station, which is nothing but your source station. That is from where you want to start your travel. The next criteria which is most important is the destination, which is your to station, like from source to destination, where from where you want to start and where you want to go. Based on this only you will do your search, because based on the from station and to station or source and destination, you will expect a list of train to be given to you, and from that list of train you can choose the train which has ticket available, or based on your choice you can pick one of the train. Now, the next most important criteria is date. Whether on that particular date on which you want to travel, whether that train runs or not. So it can happen that a certain train runs on certain days. So for the set of criteria that you have given from and to station, on that particular date, that train might not be available. So it should not show in the search list. So once you have performed the search. So this is another important criteria. Now, next criteria is your class, which tells us which class you want to book your ticket into. This can be an optional criteria. So you can basically make your search or base your search on the first three criteria and show all the class detail, like how many seats are available for each of these classes. But if you want, you can add this as part of your criteria as well. And also quota, whether you want to book your ticket in general quota or defense quota, tatkal quota, ladies quota, or senior citizen quota. So you can have multiple quotas like this. Now, based on these condition, most of your search will be based on these condition. So how you will come up with a table so that the query that is going to hit your table or hit your database will be really fast. This is one sample design that I came up with, this table structure. So this can be followed. So what I have done here is that, and this is a transaction table, this is not a metadata table. There can be a separate metadata table for capturing train detail. Now that metadata table can have train number from station to station. In place of date, it can have like on which days the train run, like a train run on all the days of the week, or it runs only one day a week. So it can have that detail captured there, and also the remaining detail, like how many seats are available or how many seats are there in a train for sleeper class, for 3AC, 2AC, 1AC, and how many seats are there for general quota, ladies quota, defense quota. So all those things can be stored in a metadata table. From there it can be pulled, so there can be like end of day batch which will read the metadata table and populate this table for every day. Usually when you have a system like IRCTC or any railway booking system, so you allow people to book a train ticket for like 3 months in advance. You don't allow them to go into the fourth month or fifth month. So every day you allow them to basically book a ticket for 3 plus 1th day. So suppose today I'm booking the ticket. So today the window will be open from today till the third month. Tomorrow it will be from tomorrow to third month, which will be 3 months from today plus 1 day. So every day there can be a batch which will pick up the read the data from that metadata table, and it will populate this particular data, this particular table, and all our search will be uh, put into this particular table. So we will search from this table only. There can be some optimization that can be done on top of that, so we'll talk about those also. So let's look at the basic detail of this particular table and what are the use of each of the column that we have. So first column is the train number, which will be like primary key for the table. If you want, you can make it a primary key. I have not made it as a primary key. Next will be your from station to station. So this will, for each train there will be multiple entry. So for each train number there will be multiple entry for and basically the train number cannot be made as primary key on its own. So it has to be in combination with from station to station, and also maybe date. Not maybe, it has to be included if you are making a primary key. But let's not make it as a primary key. It will not be a good design. I will tell why. So we have train number from station to station here, date here. Then we have sleeper seat count, all the seat count for all the classes, all the seat count for all the various quota. So what benefit we get here is whenever we make a query from this particular table based on from station to station and date, and also if we want to add class, so basically if I want to search only for sleeper class, I can simply add that, select only the sleeper class seat count, you don't select the rest. If I want to select everything, then you say select sleeper count, third AC seat count, 2 AC seat count from this particular table train detail, where from station is this, to station is this, and for this particular date. So that way your query will be, this table will be able to help in your search functionality. And also this data that we search or we populate in this table, it's very structured. So it's structured, and also there is a relation also involved between train and user and also the payment. So this table will suit RDBMS, and if in this particular scenario I will prefer that you use an RDBMS. And once you are using an RDBMS, so to further optimize your table and the query, what you can do is you can create index. So now in this particular scenario, you know, these are my search criteria, this will fall in where clause. So what will be the best set of column to create a composite index? So from here you see that these three are the mandatory ones and these two are optional field. So it's better to create your index on the mandatory field. So what we can do is we can create an index on from station to station and date. This will be good and it will work fine when you start your new website. But as and when the data starts populating in this table, what happens is that the size of this table will grow. We'll see that also, what will be the rate at which the size will grow. So okay, let's check that out. So I've done some capacity planning for this particular table. So as you see, it has 140 bytes based on these columns. Number of train, we can assume that there are 20,000 train which is running every day in India, and average stopping station per day per train is 80. So every train on an average stops at 80 station per day. So if we account for these detail, we see that the total size for this table per day will be 213 MB, and for a month it will be 6 GB. So going forward, number of train increases, number of station increases maybe. So that way this table size will also increase, and anyway even if nothing increases, it will keep on, the table size will keep on growing at 6 GB per month. So if you go 4 year or 5 year down the line or 1 year down the line, this table will be huge. And once the table grow huge, the index that you created for this table, that will also increase in size. And if the index grows in size, again your performance will be hit, because the index that we are creating, it's not a primary key index, it will be a normal index. So what is the other option that we have to optimize our search query? So another option that we have in case of RDBMS is that we partition this table. So the best thing that we can do is we can partition it based on date. So for each date, we will have a from station to station condition, because anytime you make a search query, you will search it for a particular date. You want to search a train for a particular date, or maybe in a range of date, like from for a week's range, you will give a range of date that from this week, this date till this date, whenever the ticket is available, I will book the ticket. So what benefit that you will get on partitioning this table on date criteria is that you will have partition pruning every time you make your search. So that way all the lookup that will happen for your data or your search criteria, it will pertain to just one partition or few partition, which will be for like a week's partition, which will depend on the range of date that you are giving. So that way the lookup will be in 200 MB, or at max if you are looking for 7 days of data, it will be the data that you will looking for will be in a range of 1.5 GB. So that is still good enough. So that way the search that will happen will be very fast for you. So I hope this setup of train detail table, which will basically act as the base for the search criteria or search lifecycle, is very clear to you. If you have any doubt in this, do put it in the comment section. I will definitely answer that. So that concludes the search lifecycle. Let's go into the booking lifecycle. So once we have completed the search, we will give the list of train to the user, and from there they will try to book the ticket. So for booking, we have two tables. First one is the booking info, second one is the booking detail. So when we book the ticket, we need to capture a PNR number. So this number will be generated by our system. I will discuss in the high level design part later during this video how you can generate your PNR number. Then while capturing other detail, you need to capture the train number for which the booking has to be made, the from station to station, timestamp is nothing but the date for which you are making this particular booking, classes for which class you are going to book the ticket, whether it is third AC, first AC or second AC. Again, quota is the are you booking under general quota or are you booking under ladies quota or tatkal quota. So that will be captured again in the booking info table, and you will have a status here. So what status does is that it will tell that whether the ticket is confirmed or whether it is in waitlisted state. And finally, you have number of seat. How many seat under this PNR number are you going to book? Whether you are going to book single ticket or multiple ticket. And train booking detail will be like, suppose number of seats are 4 under this particular PNR. So train booking detail will have 4 rows for this PNR number, which will have the passenger name, passenger age, passenger sex, ID type, ID number, seat number, and the date for which booking is done. Now, one thing that I have not considered here is the partial cancellation part. So here I am assuming that if you want to book a ticket and the ticket will be, if you have given like you want to book 4 seats, and if 4 seats are not available, so I will book your ticket in like all the ticket will go into a waiting state. Otherwise, all the ticket will go into, if the all 4 seats are available, then only confirmed booking will be done. So if I want to add partial booking or partial cancellation, if I want to support that functionality, I need to put the status column in the train booking details side also, so that I can say that okay, 2 tickets are confirmed and 2 tickets are waitlisted or RSC. Now let us look at the capacity for this. Similar to the last table, I've done capacity planning for this, and this will take around 8 GB, which will be considering both the table. Now again, when you are booking this particular seat, so this will have like one time right when you have created these record while booking. Some of the records can be updated, like status can be updated. Same thing goes here. If you have partial cancellation or partial booking, then status column will be here, that can be updated later down the time. Other than that, only time these table will be updated is when you are doing a cancellation. And second thing is, most frequently you can basically query these table, and why you can query is not you, the user will query these table because they want to see the status of their booking, or they want to check some detail about their ticket, maybe to recheck whether the ID that has been given is correct or not. So a lot of query can happen on these two table. So similar to the search criteria, these table also can be partitioned based on the time, the date field. Both the table can be partitioned based on date field, and you can create a index, and the index in this scenario can be created based on PNR number, because PNR number will be unique for each ticket. So, and of course I will tell you how to generate PNR number later down the video. So this is for the booking train part, the how you will handle the database. Next is payment. Payment is very simple. So here we will capture the PNR number for each payment, transaction ID, method of payment, whether it was internet banking, cash or UPI, amount, status, the status can be the payment was made, successfully or it was failed, or those things can be captured, remarks can be captured, and date of payment can be captured. Other than these, you can also capture the ID. That ID will be like if the mode of payment was internet banking. So maybe in a state of cancellation, you want to refund the money. So where the money will go? So if you have to refund the money, in that case you need to capture those account number, and you need to capture, if it is UPI, then UPI ID. If it is cash, then it has to be done over the counter. So for those, you can capture that detail in this table itself, or you can create another table which can be used for cancellation, and you can capture those details there. And anything else that you need to know about payment, you can check the payment gateway video for that. And for capacity planning, this will be taking like around 4.5 4.6 GB space. And this table, the payment side will be really simple, because it will be an atomic transaction that will happen, and there will be no race condition or nothing sort of that. So this will be a very simple API that you will build and store. Next is your overall capacity estimation, that has to be done for creating your database. So if you see train detail per month, it takes 6.2 GB. The booking part, it takes 8 GB. The payment takes 4.5 GB. So overall size over a period of 5 years, it can grow up to 1 TB. Now this is the part which, this is the capacity of the table that is in scope of this current video. Apart from this, you will create multiple tables, so you have to account for those tables as well when you are building a complete system. In case of interview, you can basically discuss with your interviewer that on which area you need to focus, and you need to come up with the capacity estimation for that particular set of the table only. So that is why here I took only these tables which are in scope of this video. So once this is done, let's talk about the important APIs that will be involved. So first is user service. So when you create user service, you should have an API to create your user, and then post details. So this will be to capture, suppose you book ticket regularly, so you can basically add your ID, phone number, email ID, all those things in your profile. So next time when you book your ticket, those things can be pulled from user data itself rather than you keying in the form. So that is where post user detail will come handy. Next is for train search. So train search will have two basic services. One will be to list your train. So this will be the master thing that will, from where you will pull this data, is the train detail table, which we talked about in the life cycle of search. And other than that, you can have a get train route. So this will be based on the table that I talked about, that train metadata table, where you have the metadata of the train stored, which will tell that the for station, from station to station, and for which days the train runs, and that will basically be main table for this particular API. Then for booking ticket service, you will have your generate PNR and book ticket. Now, you remember I told when we were discussing about booking, that I'll tell you how PNR will be generated. So for PNR generation, if you see in the capacity estimation, we saw that we book like 1 million ticket every day. So every day we exhaust 1 million PNR numbers, and over a period of time we will be exhausting a lot of PNR number. Now these booking counter will be across country, and people can book basically online also. So how do you generate the PNR in a fast way and in a way that it is unique for everyone? So one way to do this, or the PNR generation, is you follow the same approach that we used in our video where we created tiny URL. So if you have not watched that video, you can check out that video as well, how we generate a short URL for a long URL. So there you see we used Zookeeper, which will basically handle multiple applications server, and which is you can use anything which can do a cluster management, not the Zookeeper. In that example I use Zookeeper, that is why I'm telling. And from there you can allocate multiple application server some random number, and based on those number you can generate the PNR. So check out that particular video to see the detail of how these allocation can be done and how this system can be scaled. So this generate PNR can be a system in itself, and this will be a big system in itself because it will require a lot of setup, lot of application server and cluster managers. And this will be another key system that will be integrated as part of the ticket booking system. The next service is the book ticket service. So this book ticket service will take input as a train detail, which you will get from list train API, and so it will be one of the train from the list that you are getting, and the user detail, which you can get from your basically database. You can pull from there. So these two things has to be passed, and these two things will be used for booking your ticket. Next is the cancel ticket. So this is the reverse flow. For cancellation, you just need to pass the PNR. So again, here we are considering that we are only cancelling the complete ticket, or we are not cancelling the ticket at all. So partial cancellation is not handled. If you have to handle partial cancellation, then multiple things will be required, like out of those, if the ticket has 4 members, then which member you want to cancel. So some extra detail will be required here, the user detail. For payment service, you will have payment processing, and this payment processing is nothing but population of that particular table. And once that table is populated, it will make a call to the payment gateway. Check out the video of the payment gateway also. That also I have already done in detail how you can do payment processing. And once that payment processing is done, so it will have two purpose. It will store the data in the database for payment that we saw, and it can have two more API, which will be to initiate your payment and initiate your refund. So initiate payment will be the normal flow where you deduct the money from bank account. Again, these two will be routed through payment gateway only. So it will basically make a call, and here we will have the PNR and the transaction ID. Transaction ID is the unique ID which we will use, which will generate similar to how we generate PNR for the complete transaction. So if you remember the payment table, there we had a column for this transaction ID as well. So this is the important APIs for payment. Now the last one is the notification service. So notification will have different kind of notification, like your SMS, email, or you can also send a email or WhatsApp notification saying that what is the current status of your train if you have already booked. So these are the few important service. Now after that, we'll look into a high level design of this particular train booking system. So for high level design, we have a UI. From UI, we will call the load balancer. This is pretty much the common part. Then we have a user account service which will populate the user database. So this will be an RDBMS, because again the user data will be really structured and it will be relational data. For searching of the train, we will have another database. This will again be a RDBMS. The same reason, if you see the table structure of the search that I have given, it was all relational and it was structured data. So you can use RDBMS here. So when you this search service, it will talk to this particular database. So from search, this task will be basically orchestrated. So these two will be separate microservice data running, and connection between these two can be done using Saga pattern. So you can use either orchestration or choreography as you wish. But if you use orchestration, then you have to bring in like a way so that these two can talk to each other, asynchronous way. So you might have to introduce a queue in between. In choreography, you can basically just make a call from train search and to the book ticket service, or one of the service of the book ticket. So this booking service, once it is done, then this whole part will be like either orchestrated or it can be choreographed based on your requirement or based on your design. For me, I'm using like choreography here, so these call can go one after the other. So train search, then book ticket, then do the payment is done, then it will go back to the book ticket, allocate the seat. Once seat allocation is done, then basically send to the caller notification service, and once notification service is called, it will send SMS or email, and it will email the ticket to the user. Now the last flow will be the cancellation flow. So cancellation flow will also talk to this train DB because we need to check the PNR which we have to cancel. Once this is done, it will make a call to payment because it will check the transaction ID for which the reversal has to be made or the refund has to be made. And finally, once the cancellation is done, it will call notification service and notification will be sent to the user. So this is the overall architecture or a high level architecture of the train booking site. Do let me know in the comment section if you have missed anything or if I have missed anything in the explanation part, or if you're expecting something else from this particular video. Do let me know and I will cover that part as well. I will try to clear your doubt like I have always been doing. So that is it for this particular video. Thanks for watching Tech Granth. Do like this video if you reached here and subscribe to the channel and share with others. Thank you for watching Tech Granth. Bye.